Every civilization that has ever kept records has remembered the same event. The Sumerians remembered it, the Hebrews remembered it, the Greeks, the Hindus, the Aboriginal Australians whose oral traditions stretch back further than any other culture on Earth, the Hopi, the Maya, the Norse. Cultures that never traded, never met, never shared a single word of language, all remember a time when the water rose and the world was wiped clean. More than 500 flood narratives have been documented across every inhabited continent. 500. That is not a coincidence. That is not one culture borrowing a good story from another. That is a memory, and memories, especially the ones that survive 10,000 years, do not persist without a reason. Here is what makes this unsettling. Modern science is no longer dismissing these stories. In the last 2 decades, marine geologists, ice core analysts, and climate scientists have been quietly assembling a picture of what actually happened at the end of the last ice age. And the picture they are building looks disturbingly close to what those ancient storytellers described. Not metaphorically close, physically close, measurably close. There is a question buried inside all of this, and it is the question that will carry us through tonight. What if the oldest stories on Earth are not myths? What if they are data encoded in the only format that could survive the collapse of everything else? A human voice telling a child what happened, so the child could tell their children, so the memory would outlast the stone. The answer is scattered across the globe, buried in ice 2 kilometers deep, locked inside the crystal lattice of cave formations, pressed into the layered mud of ancient lake beds, carved into limestone pillars that no one was supposed to find, and written in neat columns of cuneiform on a 4,000-year-old clay prism by scribes who tracked Venus across the sky with a precision that modern astronomers did not match until the 20th century, and who recorded kings with reigns of 28,000 years as calmly as they recorded the price of barley. Tonight I am going to take you through that evidence. We will travel backward through 12,000 years of ice, stone, ocean, and myth. We will walk through drowned coastlines and buried temples. We will sit with the scientific debates that are still unresolved, and I will be careful to tell you what is established, what is debated, and what is simply not known. And at the end, we will return to a question about what it means to remember and what it costs to forget. That question will not fully close until the final minutes. Keep it with you. Now, let your breathing slow. Let the noise of the day drain from your shoulders. Close your eyes if you would like. You will not need visuals for this. Let the ancient world emerge in the theatre of your own mind, where the best stories have always lived. There is no hurry here. There never is, when you are touching the deep past. Before we go further, if this kind of quiet, evidence-based journey through history resonates with you, a gentle luck helps others find these stories when the night grows long. And I am curious, where in the world are you settling in tonight? Leave a note in the comments if you like. There is something comforting about knowing we're all drifting through the same ancient mystery, scattered across different time zones, beneath different constellations. Now, let us travel back, not centuries, but millennia. Roughly 12,900 years ago, give or take a few lifetimes, our planet was in the middle of a slow, welcome thaw. The last great ice age, which had gripped the northern hemisphere for tens of thousands of years, was finally loosening its hold. Glaciers that had stood like frozen mountain ranges across Canada, Scandinavia, and northern Europe were retreating. Sea levels were rising. The world was warming, and with that warmth came the green spread of forests, the return of animal herds, and the expansion of human communities into territories that had been sealed in ice for longer than anyone could remember. Life was getting better. For the first time in millennia, humans were not merely surviving. They were expanding, following the retreating ice northward into Scandinavia, spreading across the newly exposed continental shelves of Southeast Asia, where the lower sea levels had revealed vast lands now called the Sunda Shelf, connecting islands that are today separated by deep ocean water, settling the coastlines of what would become the Persian Gulf, which at that time was a fertile river valley, green and lush, fed by the Tigris and Euphrates long before those rivers reached the sea. The world was opening. The humans who lived in it were adapting, innovating, creating. They were painting caves, crafting tools of increasing sophistication, developing early forms of trade across distances that suggest networks of trust and communication, burying their dead with care and ceremony, placing offerings beside the bodies, arranging the limbs with deliberate attention. They were, in every sense that matters, us. and the future stretched out before them like a warming plain after winter. And then, without warning, the warmth stopped. In a matter of decades, possibly even years, temperatures in parts of the northern hemisphere plummeted by as much as 10 degrees Celsius. The rapidity of this cooling is difficult to overstate. Greenland ice core records indicate that the most severe phase of cooling occurred over as few as 3 years, based on analysis of annual dust and chemical layers. Snow returned to places that had been greening for centuries. The glaciers, which had been retreating, stabilized or even advanced again. Rivers froze. Forests died. The animals that had ventured north found themselves trapped in a tightening noose of cold. This was the Younger Dryas, named after a small white wildflower, Dryas octopetala, that thrives in Arctic conditions and whose pollen suddenly reappeared in European lake sediments at precisely this moment in the geological record. It lasted approximately 1,200 years, from roughly 12,900 years ago to about 11,700 years ago, and then, just as abruptly as it had begun, it ended. The world warmed again, faster this time, and the ice retreated for good. The evidence for the Younger Dryas is not speculative. It is one of the most thoroughly documented climate events in Earth's history. The proof comes from multiple independent archives, each one a different kind of memory that the planet keeps. Greenland ice cores drilled from kilometers deep within the ice sheet show a sharp drop in oxygen 18 to oxygen 16 ratios at the onset of this cold period, a proxy that scientists use to reconstruct ancient temperatures because water molecules containing the heavier oxygen isotope evaporate less readily in cold conditions. These cores are extraordinary archives. Each layer of compressed snowfall traps tiny bubbles of ancient atmosphere, dust particles from distant volcanoes, pollen from vanished forests, even traces of the cosmic debris that filters down through the upper atmosphere. By counting and analysing these layers, scientists can reconstruct the climate of any given year, going back hundreds of thousands of years, with a resolution that approaches the annual. Antarctic ice cores reveal complementary patterns, a phenomenon scientists call the bipolar seesaw. When the north cooled, the south warmed. This is not a coincidence, but a consequence of how heat is distributed by ocean circulation. When the AMOC weakens or shuts down, the heat that would normally be transported northward remains trapped in the southern hemisphere, warming the Antarctic while the Arctic freezes. The Younger Dryas was not a local anomaly. It was a reorganization of the entire global climate system, and the evidence extends far beyond polar ice. Lake sediments from sites as distant as Japan and Germany preserve the signal. At Lake Suigetsu in Japan, annually laminated sediments called varves, layers so fine and regular that they can be counted like tree rings, record the Younger Dryas onset and termination with remarkable precision. The beauty of varve records is that they provide an independent clock. Unlike radiocarbon dating, which must be calibrated against other records, varves simply count the years, one layer per season, laid down in the still waters of a lake bottom. The Suigetsu varve chronology is so precise that it has been incorporated into the INTCAL International Radiocarbon Calibration Dataset, the standard against which radiocarbon dates around the world are measured. A 2015 varve analysis from a German paleolake suggested the cooling may have proceeded in 2 stages, first affecting latitudes around 54 to 56 degrees north, and then spreading further northward several centuries later, adding texture to what had been assumed to be a single simultaneous event. These varve counts have been cross-validated against uranium-thorium ages from speleothems, the mineral formations that grow inside caves when groundwater deposits calcium carbonate over thousands of years. The oxygen isotope ratios trapped in these mineral layers reflect temperature and rainfall conditions at the time of deposition, and uranium-thorium dating can pin their ages with uncertainties as small as a few decades, even for samples tens of thousands of years old. A 2024 study using cryogenic cave carbonates from Britain and a complementary 2021 study from the Dolomites employed this special variety of mineral deposit, which forms only when water freezes slowly in caves at temperatures just below 0 degrees Celsius. These deposits provided direct evidence that permafrost persisted in the British and Alpine uplands throughout most of the Younger Dryas. Speleothems from caves in northern Spain recorded a gradual mid-Younger Dryas climate shift beginning around 12,450 years ago, as the polar front slowly migrated northward and the AMOC began to resume partial function. This mid-Younger Dryas transition took roughly 300 years to propagate from southern to northern Europe, a detail preserved in both cave records and lake valves. Together, these independent archives create an interlocking chronology of extraordinary precision. Ocean floor cores, pollen studies, and chemical signatures locked within stalagmites across multiple continents all confirm the same story. Something dramatic happened to Earth's climate nearly 13,000 years ago, and then it happened again in reverse, roughly 1,200 years later. The transition out of the Younger Dryas was, if anything, even more abrupt than its onset. Ice core data suggests that temperatures in Greenland rose by as much as 10 degrees Celsius in a single decade. A single decade? That is not geological time. That is a human lifetime. The generation that shivered through the final years of the Younger Dryas could have lived to see a world that was unrecognisably warmer. Now imagine being alive during this. Imagine your grandparents telling stories of how the world was warming, how the great herds were moving north, how the rivers ran full and the fish were plentiful, and then watching the cold return relentlessly, year after year, pushing the animals south, freezing the rivers, burying the landscape under snow that did not melt come spring. This was not an abstraction for the people who lived through it. This was their world ending, and end it did for many. The Younger Dryas coincided with the extinction of more than 35 genera of large mammals in North America alone. Mammoths, mastodons, saber-toothed cats, giant ground sloths, American horses, camels, the short-faced bear, standing taller than any modern bear, all gone within a geological heartbeat. The Clovis culture, one of the earliest well-documented human cultures in the Americas, characterized by their beautifully crafted fluted stone spear points, disappeared from the archaeological record at precisely this boundary. Something ended their way of life. Let us stay here for a moment, in that vanished world, because it is a world worth imagining before it disappears. Before the Younger Dryas, Ice Age North America was teeming with life on a scale that is difficult to comprehend today. Herds of woolly mammoths, some standing 4 meters tall at the shoulder, moved across the tundra in groups of dozens or hundreds, their great curved tusks catching the low Arctic light. Mastodons, smaller and stockier than their mammoth cousins, browsed in the spruce forests of the eastern woodlands. Saber-toothed cats with canine teeth nearly 18 centimeters long stalked prey through the grasslands. Giant ground sloths, some weighing more than 4 tons, lumbered through the forest like living boulders. Short-faced bears claimed the open plains. American horses, not yet extinct, galloped in herds that would have rivaled the buffalo. Camels, dire wolves, giant beavers the size of black bears, glyptodonts, armoured cousins of the armadillo, large enough to shelter a crouching human beneath their shells. Among these animals moved the Clovis people, some of the earliest well-documented human inhabitants of the Americas. They are named for the distinctive stone spear points first found near Clovis, New Mexico, in the 1930s. Beautifully fluted points, crafted with a technique so precise that modern flint knappers still study them with admiration. The Clovis people were not primitive wanderers. They were skilled hunters, toolmakers, and travellers, and their distinctive points have been found across nearly all of North America, from coast to coast, suggesting either a remarkably mobile population or the rapid spread of a highly effective technology. The craft involved in making a Clovis point is extraordinary. The flint knapper had to select the right stone, often travelling considerable distances to obtain high-quality chert or obsidian. The stone was heated to a precise temperature to improve its flaking properties, and then a long channel flake was removed from the base in a single, controlled strike, a technique so difficult that it takes modern practitioners years to master. These were not simple people making simple tools. These were artisans working at the edge of what stone technology could achieve. Some archaeologists believe the Clovis people were among the first humans to enter the Americas, crossing from Siberia via the Bering Land Bridge during the Ice Age, following the so-called ice-free corridor between the Laurentide and Cordilleran ice sheets. Others argue for earlier arrivals, pointing to sites in South America and along the Pacific coast that predate Clovis by thousands of years. Monteverde in Chile, with its hearths and preserved plant remains, is now widely accepted as pre-Clovis, with occupation layers dated to approximately 14,500 years ago. The Friedkin site in Texas has yielded stone tools from sediment layers beneath a Clovis horizon. The white sands footprints in New Mexico, dated using radiocarbon analysis of seeds from an aquatic plant embedded in the same layers, suggest human presence as early as 23,000 years ago, though this dating has been challenged on methodological grounds and remains one of the most actively debated findings in American archaeology. The question of when and how humans first reached the Americas remains one of the most actively debated topics in archaeology. But what is clear is that by the time the Younger Dryas arrived, humans had been in the Americas for at least several thousand years and had developed sophisticated cultures adapted to the megafauna-rich environment of the late Pleistocene. And then, at the Younger Dryas boundary, both the Clovis culture and the megafauna vanish from the record. The fluted points stop appearing. The great beasts disappear, species after species, in what appears to be a geologically instantaneous extinction event. What happened? The debate over what killed the megafauna is one of the longest-running arguments in paleontology, and it has not been settled. The leading candidates are climate change, human overhunting, disease, and, more controversially, a cosmic impact. Increasingly, researchers favour multi-causal models that allow these factors to reinforce one another. A 2024 synthesis published in Cambridge Prisms, Extinction, and a separate meta-analysis in Science argued that rapid climate change likely served as the primary stressor, fragmenting habitats and disrupting the migration corridors that large herbivores depended upon. Human hunting, rather than being the sole driver, may have delivered the final blow to populations already weakened and isolated by habitat loss. This is sometimes called the synergy model, and it has gained considerable traction because it can account for the fact that similar megafauna extinctions occurred on different continents at different times, each coinciding not with a single cause, but with the arrival of the same combination: rapid climate shift plus human presence. The model is compelling, though some researchers caution that the relative weight of each factor probably varied by species and by region. It is worth noting that the Clovis people themselves did not vanish from the earth. The people survived, even as their distinctive culture transformed. What disappeared was the toolkit, the fluted points, the specific hunting strategies adapted to megafauna. In the centuries following the Younger Dryas onset, regional cultures emerged across North America, each adapting to local conditions in ways that their Clovis predecessors had not needed to. The Folsom culture in the Great Plains developed smaller, more finely fluted points, adapted to hunting bison rather than mammoths. The Dalton culture of the southeastern woodlands shifted toward foraging strategies suited to the forests that were replacing open grasslands. The Western stem tradition along the Pacific coast developed tools suited to coastal and riverine environments. This diversification, from a single broadly distributed culture into many regionally specialized ones, is itself a signature of stress and adaptation. The continent-wide way of life had become untenable. People did what people always do. They adapted, or they moved. But the scale of the ecological loss remains staggering regardless of its cause. An entire ecosystem, millions of years in the making, erased. More than 35 genera of large mammals in North America alone. Similar extinctions were unfolding elsewhere. Giant wombats and marsupial lions had already vanished from Australia during an earlier wave. Woolly rhinoceros and cave bears were disappearing from Europe. The timing varied by continent, but the pattern was consistent. Wherever rapid climate change and human expansion overlapped, the megafauna did not survive. The image is indelible. A continent of giants, and the human hunters who had learned to thrive among them, swept away in the space of a few centuries. The question that has fueled more than a decade of fierce scientific debate is what caused the Younger Dryas itself. Let us walk through this carefully, because the science is layered and the disagreements are real. The mainstream explanation, supported by a strong majority of climate scientists who study this period, centers on ocean currents, specifically the Atlantic Meridional Overturning Circulation, often abbreviated as the AMOC. This is the vast system of deep ocean currents that acts like a conveyor belt, pulling warm tropical water northward along the surface of the Atlantic and sending cold, dense, salty water back south along the ocean floor. It is the reason that London, which sits at the same latitude as Calgary, Canada, has mild winters instead of brutal ones. The AMOC is, in essence, Western Europe's central heating system. The hypothesis goes like this. As the great North American ice sheets melted, an enormous body of meltwater accumulated behind ice dams in what is now central Canada, forming a body of water called Glacial Lake Agassiz. At its peak, Lake Agassiz covered an area larger than all of the modern Great Lakes combined, holding more fresh water than exists in any lake system on Earth today. A sea of frigid, blue-grey meltwater imprisoned behind walls of ice that rose hundreds of meters into the sky. At some point, the ice dam failed. The result was catastrophic. A colossal volume of fresh water poured into the North Atlantic. Some estimates suggest the outburst flood alone may have raised global sea levels by as much as 3 meters. A torrent of ice-cold fresh water, carrying icebergs and sediment, spreading out across the surface of the North Atlantic like a cold, fresh blanket smothering the warm, salty water beneath. This sudden influx diluted the salty surface water that normally sinks in the high northern latitudes. The sinking that drives the deep ocean circulation. The conveyor belt shut down. Without the northward transport of tropical heat, the northern hemisphere plunged back into near-glacial conditions. It is an elegant explanation, and it is well supported by oceanographic models. But it is not the only explanation, and the Lake Agassiz outburst itself raises questions. The precise routing of the meltwater remains debated. Some researchers argue the flood drained north through the Mackenzie River into the Arctic Ocean rather than east into the Atlantic, a routing that would deposit the freshwater in a different ocean basin and potentially trigger the AMOC shutdown through a different mechanism. Others have noted that the expected sea level fingerprint of such a massive freshwater pulse has not been convincingly detected in coral reef records from the tropics, though this may reflect the difficulty of resolving a rapid event in slowly accumulating reef archives. A 2021 study in Nature Geoscience proposed that the meltwater may have entered the ocean through multiple pathways over a longer period than a single catastrophic burst, which would require a more nuanced triggering mechanism than the standard model suggests. Alternative triggers have also been proposed. Some researchers have pointed to changes in atmospheric circulation patterns that could have redirected meltwater routing without a single catastrophic dam breach. Others have suggested that the AMOC, already weakened by tens of thousands of years of gradual deglaciation, may have been poised at a critical threshold where even a modest perturbation could have tipped it into a shutdown state, a concept that resonates uncomfortably with current discussions about modern AMOC vulnerability. The Younger Dryas may have been, in the language of complexity science, an emergent system failure, triggered not by a single cause but by the interaction of several destabilizing forces acting simultaneously on a system already under stress. This interpretation, while less narratively satisfying than either a comet or a flood, may be closest to the truth. In 2007, a team of researchers led by Richard Firestone published a paper in the Proceedings of the National Academy of Sciences proposing something far more dramatic. They argued that the Younger Dryas was triggered not by meltwater, but by a comet. Specifically, they proposed that a large fragmented comet either struck the Earth or exploded in the atmosphere approximately 12,800 years ago, unleashing energy equivalent to thousands of nuclear weapons, igniting continent-wide wildfires, and triggering the sudden cooling that followed. The evidence they pointed to was a thin layer of sediment found at sites across North America, right at the boundary where the Younger Dryas begins. Within that layer, they reported anomalous concentrations of nanodiamonds, metallic microspherules, elevated levels of platinum, melt glass subjected to temperatures exceeding 2,000 degrees Celsius, and vast quantities of soot consistent with the burning of approximately 10% of Earth's biomass. The scientific community responded with immediate skepticism and not without reason. No impact crater from this proposed event has ever been found. A 2023 comprehensive review by Holliday and colleagues argued that of the 12 original lines of evidence, 7 had proven non-reproducible, and that the remaining signatures could be explained by ordinary terrestrial processes. But the story did not end there. In a detailed rebuttal published in Earth Science Reviews in late 2024, Sweatman and colleagues systematically challenged the Holliday review, arguing that several of its criticisms relied on outdated studies or methodological misunderstandings. They noted that by the time of their writing, the microspheral evidence had been reproduced at 38 sites on 4 continents, nanodiamonds at 24 sites, platinum group element enrichments at 39 sites, and shocked quartz at the first 3 sites to undergo intensive analysis. In August of 2025, Christopher Moore of the University of South Carolina published results from sediment cores taken from the ocean floor in Baffin Bay, Greenland. For the first time, impact-related materials, including platinum anomalies and high-temperature melt glass, were found not in terrestrial sediments where contamination is always a concern, but deep beneath the ocean in layers precisely corresponding to the Younger Dryas boundary. The honest assessment is this: the debate remains genuinely unresolved. The impact hypothesis is not fringe science. It is published in peer-reviewed journals, it has survived multiple rounds of attempted refutation, and the evidence base continues to grow. But it also has serious unresolved problems, foremost among them the absence of a crater. The meltwater hypothesis remains the consensus view among the majority of researchers, but it too has gaps and complications. What both sides agree on is that the Younger Dryas was a real devastating event, and that Earth's climate is capable of sudden dramatic shifts on timescales measured in decades, not millennia. Let your thoughts slow here for a moment. Breathe. Feel the pillow beneath your head, the weight of the blanket over your body. You are safe. You are warm. The cold snap that seized the world 13,000 years ago is long gone, but its echoes still reach us through ice cores and ocean sediments and the ruins of cultures that vanished in its grip. Let those echoes become something quieter now, like distant thunder heard through the walls of a warm room. There is a world beneath the waves that most people never think about. Not a mythical world, a real one. A world of drowned coastlines, submerged forests and lost settlements that sank beneath the rising seas as the great ice sheets melted and the oceans reclaimed what the glaciers had exposed. When the last ice age was at its peak, roughly 20,000 years ago, sea levels were approximately 120 metres lower than they are today. That is the height of a 40-storey building, and that difference was not evenly distributed. In some parts of the world, the retreating shoreline exposed enormous expanses of continental shelf, lands that were, for thousands of years, the most desirable real estate on Earth. Flat, fertile, close to water, rich in fish and shellfish, and the game animals that gathered at the water's edge. Consider the Sunda Shelf, the vast continental platform that today lies beneath the shallow seas between the Malay Peninsula, Borneo, Sumatra and Java. During the Ice Age, much of this area was dry land, a region sometimes called Sundaland. It was roughly the size of Europe. It connected islands that are now separated by hundreds of kilometres of ocean. People lived there. Based on what archaeologists have found on the surrounding islands and coastlines, they likely hunted, fished, built shelters and created communities. And as the seas rose, they were forced to retreat generation after generation to higher ground. The cultures of island Southeast Asia, the Malay world, the Philippines, appear to have emerged at least in part from this slow displacement. Their ancestors did not always live on islands, they lived on a continent that drowned. Consider the Persian Gulf. Today it is a shallow body of salt water, nowhere more than about 90 metres deep. But during the Ice Age, it was a river valley, irrigated by the Tigris and Euphrates, surrounded by freshwater springs. Archaeological researcher Geoffrey Rose of the University of Birmingham has argued that this now submerged basin may have been one of the most attractive landscapes for human settlement in the entire Middle East during the late Pleistocene and early Holocene. As the waters rose, the communities living there would have been pushed up and out, into Mesopotamia, into the coastal regions of what are now Iran and Arabia. Some researchers have speculated that these displaced communities may have carried with them the organisational skills, the cultural memories, and perhaps the stories that would eventually crystallise into the earlier Sumerian civilization. It is an intriguing possibility, though direct evidence remains elusive, and the oldest Sumerian city, according to their own traditions, was Eridu, a settlement at the edge of the marshes, founded, they said, at the place where the world began, where dry land met water, where the fresh water and the salt water mingled. Whether this tradition preserves a genuine memory of displacement from the flooded Gulf basin, or whether it reflects a more universal mythological pattern, is something we may never know for certain. Consider the Black Sea. In the early 1990s, marine geologists William Ryan and Walter Pittman proposed that approximately 7,600 years ago, the Mediterranean Sea, swollen by post-glacial meltwater, breached the narrow land bridge at what is now the Bosporus Strait, and poured into the Black Sea basin with a force 200 times greater than Niagara Falls. Robert Ballard, the underwater explorer famous for locating the wreck of the Titanic, subsequently discovered evidence of an ancient shoreline 150 metres below the current surface of the Black Sea, along with stone tools and the remains of freshwater mollusks that had once lived along the lake's edge. If Ryan and Pittman are correct, then the communities living along the shores of that freshwater lake would have experienced a flood of almost unimaginable proportions, their homes, their fields, their entire world swallowed by the sea within months, possibly weeks. They would have fled in every direction, carrying nothing but their children and their stories. And those stories, argue Ryan and Pittman, may have been passed down through 3,000 years of oral tradition, until they were finally written down in Mesopotamia as the story of a great flood. This remains debated. The catastrophic scale of the Black Sea flooding has been challenged by geologists who argue that the inflow was more gradual. The connection to flood mythology is speculative, but the physical evidence, the submerged shoreline, the freshwater sediments, the tools, is real. Something happened. People were displaced, and the memory in some form endured. Now consider Doggerland. 12,000 years ago, what is now the North Sea between Britain and the European mainland was dry land. A vast, fertile lowland of rivers, marshes, lakes, and forests. Archaeologists call it Doggerland, named after the Dogger Bank, a shallow sandbank where Dutch fishing vessels called doggers once operated. This was not empty wilderness. It was, by many estimates, the most attractive landscape in northwestern Europe for Mesolithic hunter-gatherers. Thousands of people lived there. At its greatest extent during the last glacial maximum, it was a continuous landmass stretching from what is now eastern England to Denmark and the Netherlands, crossed by the ancestors of the Thames and the Rhine, which merged into a single great river system that flowed westward through what would become the English Channel. You can almost see it, if you close your eyes. A broad plain, gently rolling, threaded with rivers that glinted silver in the long northern light, stands of birch and oak clustered along the waterways, herds of red deer and aurochs moving through clearings, their breath steaming in the cool morning air, flocks of waterfowl rising from the marshes in clouds so thick they briefly dimmed the sun, and along the riverbanks smoke rising from small fires, the signs of human habitation, people building shelters from wood and animal hide, children playing at the water's edge, elders sitting together, telling stories of where the deer could be found, of the fish runs in autumn, of the great cold that their grandparents' grandparents remembered. The University of Bradford's Europe's Lost Frontiers project has spent more than 2 decades mapping this drowned world. Using seismic survey data originally collected by oil companies drilling in the North Sea, they have reconstructed a digital model of nearly 47,000 square kilometres of Doggerland's ancient topography, identifying river systems, lake beds, coastlines, salt marshes, and what appear to be the locations of ancient settlements. In 2025, they released an interactive simulation showing the entire process, from a vast landmass at the height of the last ice age, 20,000 years ago, to its slow disappearance over the following 15,000 years, first shrinking to an archipelago, then to a single island, and then vanishing entirely beneath the waves. The artefacts that modern fishermen still occasionally pull from the North Sea tell a story of a sophisticated Mesolithic culture. Antler harpoons barbed with intricate precision, flint tools expertly knapped, a 13,000-year-old aurochs bone etched with a zigzag pattern, dredged from the waters near Brown Bank, perhaps the oldest known artwork from the Netherlands. Human bone weapons dating to 11,000 years ago have been recovered, tools crafted from the bones of the dead themselves, suggesting ritual practices we can barely imagine. Around 6,200 BCE, a massive section of the continental shelf off the coast of Norway collapsed into the deep ocean. This was the Storegga Slide, one of the largest submarine landslides of the Holocene, displacing approximately 3,200 cubic kilometres of sediment and triggering a tsunami that sent waves racing across the North Sea. The trigger is believed to have been an earthquake that destabilised sediments left behind by the retreating glaciers, sediments that had accumulated over thousands of years and were loaded with methane hydrates, frozen crystals of methane gas trapped in the seabed that expand explosively when disturbed. Models suggest waves reached 20 to 25 metres on the Shetland Islands, 10 to 12 metres along the Norwegian coast, and up to 5 metres along the coast of eastern Scotland. Sand deposits attributed to this tsunami have been found as far as 80 kilometres inland and 6 metres above modern tide levels. In 2024, new microfossil and geochemical evidence from Budler Bay in Northumberland tentatively extended the known southerly reach of Storegga deposits into northeastern England. The researchers noted the ongoing challenge of distinguishing tsunami deposits from those left by severe storms. Recent work by the Europe's Lost Frontiers team recovered the first confirmed evidence of the Storegga tsunami from the southern North Sea itself, in a sediment core from a submerged river valley. Their multi-proxy analysis identified a sequence of 6 unusual deposit layers consistent with 3 main tsunami waves. Sedimentary ancient DNA from the core revealed that even after the tsunami, the remnant landscape briefly recovered, grazed by bear, wild boar and ruminants. The final inundation of Doggerland, they concluded, was not caused by the Storegga event itself, but by the inexorable rise of sea levels that continued for millennia afterward. The tsunami was devastating for the low-lying communities that remained, but it was the slow drowning, not the sudden wave, that erased Doggerland from the map. Whatever communities still clung to those last low islands would have had no warning, no understanding of what was happening when the wave arrived, and generations before that, they had already watched their world shrink. Their grandparents' fishing grounds submerged, the forests their people had hunted in since time beyond memory, gone beneath the waves. Would they not create a story about it? Would they not tell their children? Now consider all of these submerged landscapes together. The Sunda Shelf, the Persian Gulf Basin, the Black Sea, Doggerland, the continental shelves of India, of Australia, of the Americas. An estimated 25 million square kilometres of land that was above water during the Ice Age is now below the sea. That is an area roughly 2.5 times the size of the United States. And it was not empty land. People lived there. This is one of the great blind spots of the human story. We dig in the hills, we excavate the deserts, we explore the caves. But the places where the greatest concentration of our Ice Age ancestors likely lived, the fertile coastal lowlands and river valleys, are underwater. Lost. Unexcavable, at least with current technology. We are left with a history built from the evidence that survived the flood, not the evidence that was swallowed by it. This does not mean a lost advanced civilization lies beneath the waves. The material evidence for such a claim has not been found. But it does mean that the human story before approximately 10,000 years ago is far more fragmentary than most people realize. There are gaps, there are silences, and in those silences the imagination finds room to wander. Now, let us move to a place where the sand is warm and the wind carries the scent of wild thyme. Southeastern Turkey, the foothills of the Taurus Mountains, near the headwaters of the Euphrates, where the Fertile Crescent bends toward the Syrian border. It is here, on a windswept limestone ridge overlooking the Harran Plain, that you will find Göbekli Tepe. And Göbekli Tepe changes the story. Imagine the scene. You are standing on a hilltop that rises gently from the surrounding plateau. The air is dry and carries the faint mineral tang of exposed bedrock. Beneath your feet, the limestone is warm from the sun. The plain below stretches to the horizon, hazy in the afternoon heat, cut by the silver thread of a distant river. Behind you, the Taurus Mountains rise like a wall, their peaks still capped with the last of the winter snow. And before you, descending into the earth like an amphitheatre carved by giants, are the enclosures. Below you, carved into the limestone, are enormous circular structures ringed by massive T-shaped pillars, some standing over 5 meters tall and weighing up to 16 tons. The pillars are not rough-hewn slabs, they are elaborately carved. Foxes snarl from the stone, vultures spread their wings, snakes coil in elaborate patterns, scorpions extend their pincers, lions crouch, boars charge, and between the animals, abstract symbols that no one alive today fully understands. This site was first noted in a 1963 survey, but dismissed as a medieval cemetery. It was not until 1994 when German archaeologist Klaus Schmidt, who had been working at the nearby site of Nevala, decided to take a second look, that its true significance was recognised. Nevala itself was a remarkable pre-pottery Neolithic settlement, excavated between 1983 and 1991, where T-shaped pillars and carved human heads had already hinted at a previously unsuspected level of symbolic complexity among early Neolithic communities. But Nevelachori was tragically lost. The site was flooded by the waters of the Ataturk Dam reservoir in 1992, its remains now submerged beneath a Turkish lake, making it yet another piece of human heritage claimed by rising water. The artefacts that were rescued, including limestone sculptures and a carved raptor figure, were moved to the Şanlıurfa Museum, where they can still be seen. Schmidt knew from his years at Nevelachori what to look for. When he was guided to the hilltop at Göbekli Tepe by a local farmer named Mahmut Yildiz, whose family had been finding strange stones while ploughing their fields, Schmidt recognized them immediately. Not grave markers, but the tops of megaliths, buried under thousands of years of accumulated soil and debris. What followed was one of the most consequential archaeological excavations in history. Radiocarbon dating placed the oldest enclosures at approximately 9,600 BCE, making Göbekli Tepe roughly 7,000 years older than Stonehenge and 6,000 years older than the Great Pyramids. It predates pottery. It predates metallurgy. It predates agriculture. And that is the part that troubled the textbooks, because everything we thought we knew about the development of human civilization suggested that you needed settled farming communities with food surpluses before you could organize the labor required to build monumental architecture. Göbekli Tepe inverts that assumption. Here it appears the temple came first. The gathering came before the grain. As of the most recent excavation seasons, only about 10% of the site has been excavated. Geophysical surveys suggest that at least 20 large enclosures remain buried. Based on preliminary readings, one of them could potentially date back as far as 13,000 BCE, which would make it 15,000 years old, though this remains unconfirmed until full excavation and radiocarbon analysis are completed. The excavations led by Professor Necmi Karol of Istanbul University have continued to produce revelations. In 2023, a life-sized wild boar statue painted in red, white and black pigment was found in Enclosure D, making it one of the oldest known painted sculptures in the world. In the same season, at the nearby site of Karahan Tepe, a 2.3-metre tall human statue was uncovered, depicted seated and grasping its phallus with both hands, its ribs and spine carved in deep incised lines, its facial expression so vivid that Karol described it as one of the most realistic representations of its era. In 2025, human figurines interpreted as votive offerings were discovered in Structure D, and at the nearby site of Saburs, a sculpture depicting a deceased individual with sealed lips emerged, offering new evidence of Neolithic funerary beliefs. But it is Pillar 43, in Enclosure D, that has generated the most intense debate. Known widely as the vulture stone, this pillar bears an intricate scene, a headless figure, a vulture with a disc hovering above its wing, a scorpion, various other animals arranged in a pattern that, to some eyes, looks deliberate and encoded. In 2017, Martin Sweatman and Dimitrios Tsikritsis of the University of Edinburgh published a paper arguing that the animal carvings on Pillar 43 correspond to star asterisms and function as a date stamp for approximately 10,950 BCE, a date that closely matches the proposed timing of a Younger Dryas comet impact. They interpreted the disk above the vulture's wing as the sun positioned in the constellation Sagittarius at the summer solstice during that epoch. Not everyone agrees, far from it. Klaus Schmidt himself, before his death in 2014, identified the disk not as the sun but as a disembodied human head, a symbol of the soul found throughout Near Eastern pre-pottery Neolithic iconography. The current archaeological team, including Oliver Dietrich and Julia Notroff, argues that the vulture stone's imagery relates to mortuary beliefs and the soul's journey to the afterlife, consistent with evidence of skull cult practices found at nearby contemporary sites. Andrew Collins, a different researcher, proposed that the vulture represents not Sagittarius, but the constellation Cygnus, tying the pillar to concepts of a celestial gateway to the underworld. The astronomical interpretation has drawn criticism from archaeologists who note that assigning modern constellation boundaries to ancient animal carvings involves considerable interpretive freedom. The question of which stars the builders of Göbekli Tepe observed and how they categorized them cannot be answered by the carvings alone, because we do not have a Rosetta Stone for their symbolic system. What we have are patterns that can support multiple interpretations, depending on the assumptions the observer brings to them. This is the nature of working at the boundary between archaeology and astronomy in pre-literate societies, and honest scholars acknowledge the ambiguity. What everyone does agree on is that whoever built Göbekli Tepe possessed organizational abilities, symbolic sophistication, and architectural knowledge far beyond what we previously attributed to pre-agricultural hunter-gatherer societies. They quarried limestone pillars weighing many tons using only flint tools. They transported them, erected them, carved them with extraordinary precision, and arranged them in enclosures that appear to follow intentional geometric layouts. And then, around 8000 BCE, they buried it, deliberately. The entire complex was intentionally filled in with rubble and soil. The T-shaped pillars were not toppled or destroyed, they were gently entombed. Whatever this place meant to its builders, it meant enough to be carefully sealed when its time was done. Was it a ritual closure, like the sealing of a pharaoh's tomb? The end of a tradition? The passing of an age? The stones keep their silence. And Göbekli Tepe is not alone. It sits within a constellation of related sites that archaeologists are only now beginning to map. Roughly 35 kilometres to the east lies Karahan Tepe, a sister site that is proving equally revelatory. Some researchers suggest it may be among the earliest known human villages, with occupation possibly predating the construction of Göbekli Tepe by several centuries, though the precise chronological relationship between the two sites is still being established through ongoing radiocarbon work. Excavations there, which began systematically in 2019, have uncovered more than 250 T-shaped obelisks, alongside monumental ritual structures and domestic dwellings found in close proximity, challenging the idea that ritual and daily life were separate categories for these people. In October 2025, a discovery at Karahan Tepe drew worldwide attention. For the first time, a human face was found carved onto a T-shaped pillar. The face, staring from a 135 centimetres tall standing stone, featured a prominent nose, deep-set eyes, and a sharp angular jawline. Professor Karul described it as one of the clearest pieces of evidence that T-shaped pillars symbolised humans, not merely architectural elements, but abstract representations of the human form placed at the centre of communal life. Other human depictions at the site include the seated figure, a bearded head with a serpent's body emerging from a wall, and a stone floor adorned with the figure of a running wild donkey, the first such motif found on a building floor at the site. The entire region, now studied under Turkey's Taş Tepeler project, is revealing a landscape of Neolithic monumentality that no one expected. Multiple sites, spread across an area of hundreds of kilometres, sharing similar iconography, similar T-shaped pillars, similar ritual practices, all built by people who, according to the traditional model, should have been living in small bands, following animal herds, and leaving no permanent trace on the landscape. Instead, they built temples, they created art, they organised labour forces, they developed symbolic systems of extraordinary complexity, and they did all of this before they planted the first field of wheat. Current findings, reported by the Taş Tepeler team in November 2025, indicate dense Neolithic populations in the region, with continuous occupation spanning approximately 1500 years. This changes our understanding of human capability in a profound way. We are accustomed to thinking of civilization as a recent invention, a product of the last 5,000 or 6,000 years. But Göbekli Tepe and its sister sites push the boundaries of organised human endeavour back by thousands of years, into a period we used to call prehistory, as though nothing of consequence happened before the invention of writing. Something of great consequence happened. We are only beginning to understand what. There is another thread we need to follow here, one that winds through the ancient world like a river of starlight, the thread of astronomical knowledge. The idea that ancient peoples tracked the stars with precision is not controversial. It is simply true. The Babylonians developed sophisticated mathematical models for predicting eclipses and the movements of planets. The Egyptians aligned the Great Pyramid of Giza's true north with an accuracy of less than 1/15 of a degree. The Maya calculated the synodic period of Venus to within 2 hours of the modern value. The builders of Stonehenge created a monument that marks the summer and winter solstices with unmistakable precision. But what about before all of these? The people who built Göbekli Tepe lived under some of the clearest, darkest skies in human history. There were no cities, no electric lights, no pollution haze. The Milky Way would have blazed across the night sky like a river of fire, and the movements of the planets, the slow drift of the constellations across the seasons, the rhythmic dance of the moon, all of these would have been as familiar and as important to them as weather forecasts are to us. And they had time. generations of accumulated observation, passed from elders to children, refined and corrected over centuries. Axial precession, the slow wobble of Earth's rotational axis, takes approximately 25,772 years to complete one full cycle. This means that the position of the stars relative to the seasons shifts gradually over millennia. The North Star changes. The constellations visible at the solstices drift. For any society that tracked the stars carefully over many generations, this slow drift would eventually become noticeable. Whether it was noticed 12,000 years ago, and if so what significance it was given, we cannot say with certainty. But the question is worth holding. Imagine them, those ancient builders standing on their hilltop under a sky thick with stars, watching the slow wheel of the heavens, noting the way the constellations shifted across the generations. Perhaps wondering, as we do now, whether the sky was trying to tell them something. Now here is where the story takes a turn that some find exhilarating and others find troubling. This is where established facts meet the realm of theory, speculation, and the irresistible human impulse to connect the dots. We should acknowledge, before going further, that the desire to find a lost civilization is not new. It is as old as civilization itself. Plato, writing in the 4th century BCE, described Atlantis as a powerful island nation that sank beneath the ocean 9,000 years before his time. He placed it beyond the Pillars of Heracles in the Atlantic Ocean. He described concentric rings of water and land, a sophisticated government, advanced engineering, and eventual destruction by earthquake and flood. Punishment from the gods for the Atlanteans' corruption. For most of the past 2 millennia, scholars have treated the Atlantis story as what Plato almost certainly intended, a philosophical allegory about the dangers of imperial overreach and moral decay. But the story refuses to stay in its philosophical box. Hundreds of proposed locations have been suggested over the centuries, from the Azores to Indonesia. One recent candidate is the Risha structure in Mauritania, a circular geological formation in the Western Sahara that, from the air, bears a passing resemblance to Plato's description. Geologists, however, identify the Risha structure as a natural dome of layered sedimentary rock eroded into its current shape over millions of years, with no evidence of human construction. It is a striking formation. It is not Atlantis. But the fact that it continues to generate passionate discussion illustrates something important about how we relate to the deep past. We want there to be more. We want the story to be bigger, stranger, more magnificent than the evidence currently supports. And that desire, while it can lead us astray, also drives genuine discovery. Without it, no one would have looked beneath the North Sea for Doggerland. No one would have returned to Göbekli Tepe after it was dismissed as a medieval cemetery. The line between productive imagination and unfounded speculation is not always clear. The idea that civilization undergoes catastrophic resets on a roughly 12,000-year cycle has been most prominently advanced by British writer Graham Hancock, particularly in his books Fingerprints of the Gods and Magicians of the Gods, and through his Netflix documentary series Ancient Apocalypse. Hancock proposes that an advanced civilization existed before the Younger Dryas, was largely destroyed by a comet impact, and that survivors seeded the development of later civilizations. He connects this to the half-cycle of Earth's axial precession, roughly 12,886 years, noting that this number is close to the interval between the Younger Dryas and the present day. Related claims come from various sources. Some theorists connect the cycle to solar activity. Others point to ancient calendar systems as evidence. The Hindu concept of the yugas describes vast epochs through which the universe cycles, though the yuga durations operate on timescales of hundreds of thousands to millions of years, which do not align with 12,000. The Maya conceived of time in vast repeating cycles. The long count calendar, which reached the end of a major cycle on December 21, 2012, was designed to track enormous spans of time, roughly 5,125 years per cycle. The Maya never predicted the end of the world in 2012. What they marked was the turning of a great wheel, the completion of one cycle and the beginning of another. Neither the Hindu nor the Mayan system aligns with the proposed 12,000-year period. More recently, a movement called the Creative Society has promoted viral videos claiming that a 12,000-year cosmic cycle is responsible for imminent global destruction. These videos have garnered millions of views on social media. blending fragments of real science with unfounded claims. Several fact-checking organizations and climate scientists have explicitly debunked these claims, noting that they repurpose legitimate scientific concerns to promote a narrative that the evidence does not support. So what does the scientific consensus say? Professor Russell Drysdale, a paleoclimate researcher, put it clearly. In 50 to 60 years of detailed research on past climates, he stated, "There is no evidence whatsoever in the geological record for climate cycles occurring at a period of 12,000 years. Professor Chris Kirkland of Curtin University echoed this. In February of 2025, AAP Fact Check rated the claim as definitively false. The Milankovitch cycles, the well-documented orbital variations that genuinely do influence climate over tens of thousands of years, operate at periods of approximately 23,000, 41,000, and 100,000 years. None of these align with 12,000 years. The precession argument fails on basic physical grounds. Precession is a gradual shift in the orientation of Earth's rotational axis. It does not cause catastrophic events. There is no physical mechanism by which reaching the halfway point of a precessional cycle would trigger any kind of disaster. The correlation between the half-precession period and the Younger Dryas timing is, in the assessment of geologists and physicists, a numerical coincidence. And the lost civilization itself? The absence of material evidence is a profound problem. No matter how devastating a catastrophe might be, an advanced civilization that existed for centuries or millennia would leave behind abundant traces: tools, pottery shards, metallurgical byproducts, writing systems, genetic signatures in domesticated crops and livestock, foundations, mines, quarries, roads. None of this has been found. Göbekli Tepe, far from proving the existence of a lost advanced civilization, actually demonstrates something perhaps more remarkable, that pre-agricultural societies, working with stone tools and no metal, no writing, no pottery, and no domesticated animals, were far more organisationally and intellectually capable than anyone had imagined. The tools at Göbekli Tepe are stone. The techniques are consistent with millennia of working with flint and limestone. The progression from earlier, simpler structures to later, more complex ones is visible in the stratigraphic record. These people learned by doing. They improved over generations. They built something extraordinary not because someone from a vanished Atlantis taught them, but because human beings, given sufficient motivation, sufficient community, and sufficient time, are capable of extraordinary things. And this may be the most important insight, because the lost civilization hypothesis, for all its romantic appeal, actually diminishes the accomplishment of the people who built Göbekli Tepe. It says they could not have done it alone. But the archaeological evidence says otherwise. Let us pause with that thought for a moment. Breathe gently. Let it settle. Now let us talk about memory. Because the 12,000-year cycle theory draws much of its emotional power not from geology or astronomy, but from mythology. From the fact that nearly every culture on Earth preserves a story of a great flood. Analyses of more than 200 flood myths from diverse traditions around the world reveal striking structural similarities. Roughly 95% describe the catastrophe as a flood rather than another type of disaster. 88% feature a favoured family that survives. 70% involve survival by boat. The oldest known written version is the Sumerian flood narrative in the Epic of Gilgamesh, dating to approximately the 18th century BCE, though oral traditions almost certainly stretch back much further. The Babylonians told of Utnapishtim, warned by the god Ea to build a vessel. The Hebrews told of Noah. The Greeks told of Deucalion and Pyrrha. The Hindu tradition tells of Manu, saved by Matsya, the fish avatar of Vishnu. Aboriginal Australians tell of Garngur, a seagull woman who flooded the land between the Wellesley Islands and the mainland. The Hopi of the American Southwest describe a flood that nearly reached the tops of the mountains. For proponents of the cycle theory, these parallels are too consistent to be coincidental. They represent in this view the cultural memory of a single, real catastrophic event, preserved across millennia. But let us hold that gently because there are other explanations. Flooding is one of the most common natural disasters in human experience. Virtually every culture that lives near water has experienced devastating floods and independently created stories to explain them. Research in cultural transmission, a field that studies how stories change as they pass from generation to generation, suggests that many myths share structural features because they originate from a common ancestral human culture in Africa or the Near East, carried by migrating populations who then adapted the stories to their local geography. This is the phylogenetic model of myth transmission, and it does not require a single global catastrophe. It requires only human migration and the universal experience of water as a destructive force. The methodology for studying flood myths has grown more rigorous in recent decades. Scholars like Michael Witzel of Harvard University have applied phylogenetic analysis, the same branching tree models used in evolutionary biology, to trace the genealogy of mythological motifs across cultures. His work suggests that many flood narratives share a common ancestry in stories that originated in sub-Saharan Africa or the Near East more than 60,000 years ago, carried outward by migrating Homo sapiens populations. Julien Dewey, using statistical methods to cluster myths by shared structural features, has argued that certain flood narrative elements cluster geographically in ways that mirror known migration routes, rather than the distribution of a single catastrophic event. The implication is that the universality of the flood myth tells us less about a shared catastrophe than about a shared human past, a deep reservoir of narrative templates that different cultures adapted to explain the floods they actually experienced. And the post-glacial rise in sea levels was itself a world-changing event. Not sudden in geological terms, but immense. Sea levels rose approximately 120 metres from their glacial period lows. Entire landscapes vanished. Coastlines retreated by hundreds of kilometres. The Persian Gulf Basin, the Black Sea shoreline, the Sunda Shelf, all were inundated. Each local drowning would have been, for the people who experienced it, an apocalypse. Some of these inundations were punctuated by episodes of rapid rise, known as meltwater pulses, during which sea levels jumped by several metres within a few centuries. Meltwater Pulse 1A, around 14,600 years ago, may have raised sea levels by as much as 20 metres in roughly 500 years, fast enough for coastal communities to notice the change within a single generation. Geographer Patrick Nunn and historian Margaret Cook at the University of the Sunshine Coast in Australia have gathered 32 groups of Aboriginal Australian stories that appear to recall geological changes along shorelines, stories that describe peninsulas becoming islands, coastlines retreating, and the flooding of lands that once were dry. Some of these stories, they argue, preserve memories of sea level rise that occurred more than 7,000 years ago. If that is true, it represents one of the longest unbroken chains of oral history on Earth. 350 generations of remembering. 350 times the stories were told and retold, refined and preserved, because the community understood that forgetting was a kind of death. The precision of some of these oral records is striking. Stories from the Spencer Gulf region of South Australia describe islands that geologists have confirmed were once peninsulas, connected to the mainland before sea level rise severed them. Stories from the Great Barrier Reef region describe the drowning of a landscape that matches the geological evidence for the flooding of the continental shelf approximately 9,000 years ago. The stories do not use scientific vocabulary, of course. They speak of ancestral beings, of punishments and transformations, of sacred events that shaped the land. But embedded within these mythological frameworks are geographical details that correspond with remarkable accuracy to what the geological record reveals. We, with our books and our databases and our cloud storage, tend to assume that oral tradition is imprecise, but the evidence suggests otherwise. When the information is considered vital, when it is embedded in ritual and ceremony and the rhythms of daily life, oral tradition can be astonishingly accurate. The Dreamtime Stories of Australia, the winter counts of the Lakota, the genealogical chants of Polynesia, which can recite lineages spanning more than 40 generations without error. These are not mere stories, they are archives, living, breathing, singing archives, maintained by human minds across timescales that dwarf the lifespan of any library. So perhaps the flood myths are not the echo of a single cataclysm. Perhaps they are the collective memory of 1,000 local apocalypses, each devastating to the people who experienced them, each woven into song and story and passed down through generations until the original event was no longer distinguishable from the sacred. What have we lost, then, from the periods for which no oral tradition survives? What stories died with the last speakers of languages that vanished in the Younger Dryas? What knowledge was carried by the people of Doggerland, or the Sunda Shelf, or the Persian Gulf Basin that was never passed on because the communities that held it were scattered, displaced, or destroyed? We will never know. And that silence in the human record is perhaps the most eloquent argument for humility in the face of the deep past. Here is where the story turns from the ancient to the urgent, because the 12,000-year cycle theory, for all its problems, taps into something genuine. It taps into the awareness, growing among both scientists and the general public, that our planet has a violent past. And that violence was not confined to the geological deep time of dinosaurs and asteroid impacts. Some of it happened while humans were here, while humans were watching. Consider the Strega slide that drowned the remnants of Doggerland. Consider the eruption of Thera, roughly 3,600 years ago, when the volcanic island we now call Santorini tore itself apart in one of the largest eruptions of the past 10,000 years. The explosion generated tsunamis that ravaged the coastlines of Crete, likely contributing to the decline of the Minoan civilization. Consider the Bronze Age collapse around 1200 BCE, when virtually every major civilization in the eastern Mediterranean fell within the space of a few decades. The Hittite Empire, the Mycenaean kingdoms, the Kassite dynasty of Babylon. The Egyptian New Kingdom, though it survived, was never the same. Cities abandoned, trade routes collapsed, writing systems lost. The literacy rate in the Aegean would not recover for 400 years. Historians call it one of the worst catastrophes in human history, a collapse so total that it took centuries for comparable civilizations to re-emerge. The cause was not a comet or a cosmic cycle, it was a convergence. Drought, likely triggered by a climate shift in the eastern Mediterranean that modern paleoclimate studies have linked to a persistent cooling pattern in the North Atlantic. Earthquakes, striking multiple cities in rapid succession along the Anatolian fault system. The disruption of the tin trade routes that Bronze Age metallurgy depended on, tin being a relatively rare resource that had to be shipped from as far away as Afghanistan and Cornwall, and the mysterious sea peoples, raiders of uncertain origin who attacked Egypt, the Levant, and Anatolia in wave after wave, their identities still debated by historians. No single factor was sufficient. Together, they were overwhelming. The system was too interconnected, too dependent on long-distance trade, too fragile in its complexity to survive the simultaneous failure of its supporting structures. The archaeologist Eric Klein, whose 2014 book on the subject remains a standard reference, describes the Bronze Age collapse as a systems collapse, a failure not of individual components, but of the network that connected them. When the network broke, everything it supported broke with it. Does that sound familiar? It should. But the underlying fears are not irrational just because the 12,000-year cycle is unsupported. The threats are real. They are just not cyclical. Let us consider what we actually know about catastrophic risk to civilization, not from ancient prophecy, but from modern science. Begin with the most direct parallel to the Younger Dryas, the AMOC. The same system whose shutdown may have triggered the Younger Dryas nearly 13,000 years ago is weakening today. In 2024 and 2025, a series of landmark studies transformed this concern from a theoretical possibility into an active area of emergency research. René van Westen and colleagues at Utrecht University demonstrated, using high-resolution ocean models capable of resolving individual ocean eddies, that the AMOC tipping point first identified in simple models in 1961 also exists in sophisticated simulations, undermining any hope that the tipping point might be an artifact of oversimplified modelling. In October of 2024, 44 leading climate scientists published an open letter warning that the risk of AMOC collapse has been greatly underestimated. In November of 2025, Iceland declared AMOC collapse a national security risk. A physics-based indicator published in the Journal of Geophysical Research in 2025, analysing 25 different climate models, found that under a high-emission scenario, the AMOC could begin to collapse as early as 2026, with a median estimate around 2055 to 2063. A separate study from the Potsdam Institute, published in Environmental Research Letters in August of 2025, projected that the AMOC could shut down entirely after 2100 under high-emission scenarios. The consequences, according to these models, could be severe. Average temperature drops of several degrees Celsius across northern and western Europe, with some high-latitude regions potentially cooling by 10 degrees or more. Sea ice extending significantly further south. tropical rainfall belts shifting, with potentially devastating effects on agriculture for billions. Not all findings agree. A January 2025 study from Woods Hole Oceanographic Institution, using a method based on air-sea heat flux measurements rather than sea surface temperatures, found no statistically significant AMOC decline over the past 60 years. A February 2025 study in Nature examined 34 climate models and found that southern ocean winds may stabilise the AMOC against complete collapse. But even those more optimistic researchers agreed that significant weakening is almost certain, and that the consequences of even a substantial slowdown would be severe. In December of 2025, researchers at the University of California, Riverside added another dimension to the debate. Using more than a century of temperature and salinity data from the North Atlantic, they demonstrated that a persistent cold patch south of Greenland, a region that has stubbornly resisted the ocean's overall warming trend, can only be explained by a weakening AMOC. No other mechanism they found could reproduce both the cooling and the freshening of surface waters observed in this region. The AMOC has been weakening for more than a century, long before the current era of rapid greenhouse gas emissions. The mechanism is eerily similar to the Younger Dryas hypothesis. Fresh water entering the North Atlantic, disrupting the sinking of dense, salty water, weakening the conveyor belt. Different cause, the melting of the Greenland ice sheet rather than the catastrophic draining of a glacial lake. Same vulnerability. Now extend the lens beyond ocean currents. Near-Earth objects. The threat from asteroids and comets is not speculative. It is scientifically well established. The Chicxulub impact 66 million years ago, the one that contributed to the extinction of the dinosaurs, released energy roughly equivalent to 10 billion nuclear weapons. NASA estimates that tens of thousands of objects larger than 140 meters, each capable of causing regional devastation, orbit the Sun in near-Earth trajectories. As of recent catalogues, fewer than half have been identified. The Chelyabinsk meteor that exploded over Russia in February 2013, injuring more than 1,500 people and damaging thousands of buildings, was only about 20 meters across. It arrived without warning because it approached from the direction of the Sun, where ground-based telescopes cannot look. But here at least the news is cautiously hopeful. In September of 2022, NASA's DART mission successfully altered the orbit of the moonlet Dimorphos, shortening its orbital period by 32 minutes, far exceeding the threshold for success. We can move asteroids now. That is not science fiction. It happened. The European Space Agency's HERA mission, launched in 2024, is en route to study the impact site and is expected to arrive in 2026, where it will conduct detailed measurements of the crater and Dimorphos's altered orbit to refine our deflection models. The upcoming NEO Surveyor, an infrared space telescope specifically designed to detect dark asteroids that reflect very little visible light, is scheduled for launch in 2027. Because it will observe in the infrared, it can detect objects by their heat signature, regardless of how reflective they are, closing a critical gap in our current detection capability. The Vera Rubin Observatory in Chile, set to begin full science operations, will survey the entire visible sky every few nights, cataloguing millions of objects and identifying moving bodies that current surveys miss. Together, these instruments aim to catalogue more than 90% of potentially hazardous near-Earth objects larger than 140 meters within the coming decade. We are building, for the first time in human history, something approaching a comprehensive early warning system for cosmic threats. Solar storms. In 1859, the Carrington event produced auroras visible near the equator and caused telegraph systems to spark and catch fire. A similar event today would damage or destroy satellites, disrupt power grids for months or longer, and cause trillions of dollars in economic damage. In July of 2012, a Carrington-class coronal mass ejection crossed Earth's orbital path just 1 week after our planet had passed through that region of space. 1 week. The margin between normality and catastrophe was 7 days. A widely cited 2012 estimate by physicist Pete Riley suggested that a Carrington-scale event has a roughly 12% chance of occurring in any given decade, though subsequent studies using different statistical models have revised this figure downward considerably, with some estimates as low as 2% per decade. Even the lower figure represents odds that merit serious attention. The The vulnerability of our electrical grid to geomagnetically induced currents is not a hypothetical concern. During the March 1989 geomagnetic storm, which was far weaker than the Carrington event, the entire Hydro-Quebec power grid collapsed within 90 seconds, leaving 6 million people without electricity for 9 hours. The storm damaged transformers as far away as New Jersey. A Carrington-scale event would be orders of magnitude more severe. The extra high-voltage transformers that form the backbone of national grids are among the most vulnerable components, and they are also among the most difficult to replace. Each one is custom-built, weighing hundreds of tons, and requires 12 to 24 months to manufacture. There is no global strategic reserve. A study by Lloyd's of London estimated that a Carrington-scale event striking the United States could potentially leave 20 to 40 million people without power for periods ranging from weeks to years, with total economic cost estimated in the range of hundreds of billions to several $1 trillion, though the exact figures depend heavily on assumptions about grid vulnerability and recovery timelines. Think about what a sustained power grid failure would mean. Not for a day or a week. Imagine months. No electricity means no refrigeration. No refrigeration means no food distribution. No food distribution means, within weeks, the breakdown of the systems that keep cities habitable. Water pumps fail, hospitals go dark, communication ceases. These are not speculations. These are the findings of studies conducted by the National Academy of Sciences, by NOAA, and by the insurance industry. And the monitoring infrastructure, while improving, remains limited. The DSCOVR satellite, positioned at the L1 Lagrange point between Earth and the Sun, provides roughly 15 to 60 minutes of warning before a coronal mass ejection arrives. That is enough time to begin emergency grid shutdowns if the protocols are in place. In many jurisdictions they are not. Supervolcanoes. The Toba eruption, roughly 74,000 years ago, ejected approximately 2,800 cubic kilometers of material into the atmosphere, potentially causing a volcanic winter lasting years to decades. Some researchers once suggested it reduced the global human population to just a few thousand breeding pairs, though more recent genetic and archaeological evidence has cast significant doubt on this bottleneck theory, and many scientists now believe human populations were more resilient than the earlier estimates implied. The Yellowstone caldera remains active. Campi Flegrei, the sprawling volcanic system beneath the suburbs of Naples, Italy, is showing signs of unrest, with ground uplift and seismic activity increasing in recent years, prompting Italian authorities to update evacuation plans for the 300,000 people living within the caldera's most dangerous zone. The probability of a Toba-scale eruption in any given century is low, roughly 1 in 17,000, but the consequences would be civilizationally devastating. So the threat of civilizational disruption is not imaginary. It is just not cyclical. The danger does not arrive on a 12,000-year schedule. It is always present, woven into the fabric of a planet that is far more dynamic and far less stable than our daily experience suggests. We live in a civilization of extraordinary complexity and extraordinary fragility. The food on your table tonight likely travelled thousands of miles, passing through supply chains that depend on stable weather, functioning ports, uninterrupted energy grids, and a global financial system operating on mutual trust and digital infrastructure. The semiconductor chips in your phone were designed in California, fabricated in Taiwan, using lithography machines manufactured in the Netherlands, assembled in China, and shipped to you through a logistics chain that depends on the continuous functioning of all these nodes simultaneously. A single Carrington-scale solar storm could disrupt the satellite networks that GPS and global communications depend on. A significant AMOC weakening could shift rainfall patterns that billions depend on for agriculture. A supervolcanic eruption could blanket the sky in particulates for years, collapsing global crop yields. We are more interconnected than any civilization in history. That is our strength. It is also our vulnerability. A volcanic eruption in Iceland can ground air traffic across Europe, as the 2010 Eyjafjallajökull eruption demonstrated when it closed European airspace for 6 days, stranding 10 million passengers and costing the airline industry an estimated $1.7 billion. A pandemic originating in one city can reach every continent within weeks. A disruption of semiconductor manufacturing in Taiwan can ripple through every industry on Earth. From automotive to medical devices, as the world learned during the chip shortage of 2020 to 2023. A single container ship running aground in the Suez Canal in 2021 held up an estimated $9.6 billion of trade per day for nearly a week. Each of these was a relatively minor disruption. The system recovered, but each one also revealed how thinly the margins of resilience are drawn. The Younger Dryas people had one advantage over us, though they would not have recognised it as such. Their world was local. A community affected by climate change had no dependence on supply chains stretching to other continents. Their food came from the land around them. Their tools came from the stones beneath their feet. When their world changed, they adapted locally, because their world was local. Our world is not. Let us pause here and let that settle gently, without alarm. You do not need to solve these problems tonight. You do not need to carry the weight of these numbers into your sleep. But know this: the knowledge exists. The monitoring systems are in place. The conversation is happening. And awareness, even quiet awareness, the kind that comes from listening to a story in the dark, is itself a form of preparation. The ancient builders of Gobekli Tepe faced the grinding cold of the Younger Dryas. They faced the uncertainty of a world in flux, where the animals they depended on were disappearing, and the climate they had adapted to was changing beneath their feet. And their response was not to retreat. It was to build, to carve, to gather in large numbers and create something that would outlast them. Something permanent in a world of impermanence, something beautiful in a world of hardship. Perhaps that is what the cycle theory, stripped of its pseudo-scientific scaffolding, is really about. Not a literal clock ticking down to our destruction, but a metaphor for the oldest human truth, that nothing lasts forever, and that the proper response to impermanence is not despair, but creation. The 12,000-year cycle theory is, in the end, a story we tell ourselves to make sense of the terrifying randomness of catastrophe. It gives us a pattern where there may be none, a schedule, a deadline, a framework for our fear. But the universe does not operate on schedules, it operates on probabilities, and the probability that our civilization will face a serious test, whether from climate disruption, cosmic impact, supervolcanic eruption, or some convergence of risks we have not yet imagined, is not a question of if, it is a question of when and whether we will be ready. The Younger Dryas people were not ready. They could not have been. They did not understand ice sheets or ocean currents or cometary orbits. They understood only that the world they knew had ended, and that they had to build a new one from whatever was left. We are different. We have the knowledge. We have the tools. We have the DART mission and the Neo-Surveyor telescope and the rapid array monitoring the AMOC and the seismometers, watching Yellowstone, and the heliophysics satellites tracking the sun's tantrums. We have climate models growing more sophisticated each year. We have the Vera Rubin Observatory preparing to survey the sky with unprecedented completeness. We have the collective scientific knowledge of 8 billion minds, connected by a communication network that would seem like magic to the builders of Göbekli Tepe. What we may lack is the will. The ancient mystery is not whether civilization has been reset before. It is whether we will take what we know and use it before the next test arrives, whatever form it takes. Every civilization that has ever existed has eventually fallen. The Sumerians, the Egyptians, the Romans, the Maya, the Khmer, the Inca, the Ottoman. Some were destroyed by invasion, some by drought, some by overextension, some by the slow erosion of the institutions that held them together. But in every case, something survived. A story, a technique, a seed, a memory. And from those fragments, something new was built. The Sumerian king list records the kings before the flood with impossible lifespans, and then it records the kings after the flood with lifespans that gradually, over generations, shrink to normal human proportions. Before the flood, the world was mythical. After the flood, the world was human. The flood itself was the boundary, the dividing line between the time of gods and the time of men. And on the human side of that line, the scribes got to work. They recorded, they calculated, they catalogued the movements of the stars and the weights of grain, and the debts owed between merchants. They built a civilization from the mud, literally and figuratively, pressing their thoughts into wet clay that would outlast empires. There is a concept in Japanese aesthetics called mono-no-aware. It is sometimes translated as the pathos of things, the bittersweet awareness of impermanence. It is the feeling you get when you watch cherry blossoms fall, knowing that their beauty is inseparable from their transience. Perhaps civilizations are like cherry blossoms. They bloom brilliantly for a time, and then they fall. And the falling is not failure. It is the nature of things. What matters is not that they lasted forever, but that they existed at all. That someone carved a fox into limestone 12,000 years ago with such skill that we can still see the individual strands of its fur. That someone tracked Venus across the sky and recorded its movements in wet clay. That someone told a story about a flood to their grandchildren, and the story travelled across continents and millennia until it reached us, sitting in the dark, listening. The well-Blundell prism sits in its glass case in the Ashmolean Museum, small and silent. Its clay has hardened over 4 millennia into something nearly as durable as stone. The cuneiform marks are still sharp. The impossible rains are still recorded. The flood still swept over. And kingship still descended once more from heaven. In museums across the world, from Oxford to London to Philadelphia, there are thousands of cuneiform tablets, many still untranslated. Some contain accounting records, tallies of sheep and measures of barley. Some contain letters between merchants, complaints about the quality of copper shipments, requests for payment of debts. Some contain love poems. Some contain medical texts. Some contain astronomical observations of such precision that modern scholars have used them to verify the dates of ancient eclipses to the exact day. And some contain stories. Stories of heroes and floods, of cities that rose and cities that fell, of kings who lived impossibly long, and then, after the deluge, kings who lived and died as we do. These tablets are, in their way, a kind of miracle. Clay, the most humble of materials, pressed with a reed stylus and left to dry in the Mesopotamian sun, has preserved human thought for more than 4,000 years. Paper decays, hard drives fail. Cloud servers can be wiped in an instant, but clay, fired or simply left to harden, endures. Somewhere in the irony of that fact lies a lesson about permanence and impermanence that the Sumerians themselves would have appreciated. What the scribes were trying to tell us across all those centuries may not be that civilization resets on a cosmic schedule. It may be something simpler and more profound, that the world breaks and the world heals, that knowledge is lost and knowledge is found again, that the act of building, the act of carving stone and raising pillars and telling stories around a fire is itself a kind of defiance against the void, an insistence that we were here, that what we built mattered, that even if the waters rise again, someone somewhere will remember. The stars that shone over Göbekli Tepe 12,000 years ago are the same stars that shine over you tonight. The sky has barely moved. It is only we who have changed, who have risen and fallen and risen again, carrying fragments of memory from one age to the next, building on the ruins of what came before, reaching, always reaching, towards something we cannot quite name. Think of all the people who came before you, the hunters on the Ice Age plains, the builders on the hilltop, the scribes pressing their thoughts into clay, the navigators reading the stars, the storytellers gathered around fires that have long since gone cold. Every one of them faced the same darkness you face tonight, the same uncertainty, the same questions about what tomorrow would bring, and every one of them chose to keep going, to build, to carve, to tell the story, to pass the memory forward. You are part of that chain. You, lying in the dark, listening to a story about stones and stars and ancient floods. The curiosity that brought you here is the same impulse that drove someone to carve a vulture into a pillar 12,000 years ago. The same impulse that drove someone to track Venus across the sky. The same impulse that drove someone to build a telescope, a spacecraft, a sensor array that watches the ocean currents for signs of change. We are all reaching toward the same thing: understanding, connection, the sense that we are not alone in time, and you are not alone tonight. Somewhere in the world, someone else is listening to this same story, drifting toward the same sleep, thinking the same ancient thoughts, in a different time zone, under different stars, but connected by the same thread of curiosity and wonder that has connected human beings since we first looked up at the sky and asked, "What is out there?" The night is deep now. Let the weight of history settle around you like a blanket. Let the ancient cities dissolve into dream. Let the pillars of Gobekli Tepe stand guard at the edges of your sleep, as they have stood guard for 120 centuries, patient and silent, keeping their secrets until we are ready to hear them. If this journey meant something to you tonight, a like helps others find their way to these stories when the dark hours grow long. There are more ancient mysteries waiting in the playlist whenever you're ready to continue, and if you have thoughts, questions, theories of your own, leave them in the comments. I read every one. Until next time, wherever you are in the world, whatever time it is, sleep well and dream deep. The old questions will be here when you wake. The mystery will keep. The pillars still stand. The clay still holds its cuneiform. The ice still keeps its record. And somewhere, beneath the North Sea, beneath the Persian Gulf, beneath the warm, shallow waters of the Sunda Shelf, the foundations of lost worlds wait in darkness and silence, patient as stone, ancient as starlight, keeping their secrets until the day we learn to listen. Let go now. Let the story dissolve into the quiet hum of your own breathing. Let the ancient world retreat to the place where all deep knowledge lives, somewhere between waking and sleep, between memory and dream, between what we know and what we have yet to discover. Good night.